Yes guys, we're working on a different set of problems today. We're dealing with expressions that converge and simplifying them. So the first one, nice and light. Given that y converges, simplify y equals x minus 2x squared plus x cubed minus 2x to the 4 plus x to the 5 minus 2x to the 6. Just before we start, I just want to give the formula, let's write it down, of a sum that converges. And that is a, where a is the first term, over 1 minus r. So that's for people like you, Arden. So if we go on to evaluate this now, what do we notice? Well, we have no coefficient of minus 2, no coefficient of minus 2. Actually, when I say no coefficient, I just mean 1. So 1 minus 2, 1 minus 2, and so on and so forth. So the odd powers of x, their coefficient is 1, even powers minus 2. So let's group the even and odd powers. So we have x plus x cubed plus x to the 5 plus so on and so forth. And then we can plus or minus 2. So we're taking out minus 2 from all the even powers. So we have x squared plus x to the 4 plus x to the 6 and so on and so forth. Now these look, well, what's inside the brackets looks slightly similar. So we have 1, 3, 5, 2, 4, 6. So sort of trying to group everything together. So how do we factorize it? Well, just giving away. How do we make these look similar? Well, we can just keep this the same. We can even take out an x. X plus 1 plus x squared plus x to the 4 plus minus 2. Here we can take out x squared. Then we have 1 plus x squared plus x to the 4, so on and so forth. Now we can do the factorization. So we'll have x minus 2x squared, 1 plus x squared plus x to the 4 plus so on and so forth up to infinity. Now notice how we can factorize even further. X, and then we have 1 minus 2x, and this part here is just a geometric sum with ratio x squared and first term 1. So using our formula, a over 1 minus r, we have first term 1 all over 1 minus r, where r is x squared. Now if you just simplify this, x 1 minus 2x all over 1 minus x squared, and that's sufficient. We can just leave our answer like that. So nice and easy. Now with this question, y equals 1 minus 2x plus 3x squared minus 4x cubed plus 5x to the 4. Well, the first thing to notice is that the coefficient is always, or the size of the coefficient is always 1 greater than the power. And that sort of reminds us of differentiation integration. So if you were to just integrate these terms, so integrate y, we get x minus, add 1 to the power divided by the new power, so x squared plus, add 1 to the power divided by new power, x cubed minus x to the 4 plus x to the 5, and so on and so forth. Now again, what we can do is we can just sort of, well, we don't even need to split. We can just notice that this is a geometric series where a equals x and r equals minus x. So sum of integral y, sum of infinity of integral of y equals x over 1 minus x, which is 1 plus x, Well, since it's the integral of y, we need to actually integrate this. So x over 1 plus x dx, we can split the fraction like such. So minus 1 here, dx. Actually, no, we shouldn't be integrating, we should actually be differentiating with respect to x, because we integrated here. So to undo the integral, we just differentiate. So this is just 1. So that becomes, if we differentiate 1, we just get 0, so that term disappears. And minus 1 over x plus 1, well, that just differentiates to 1 over x plus 1 squared. So a pretty clean result for a funny looking series. Now we've got the same question again, but we're forced to do it a different way. Now, the way I saw this is by writing every power of x with coefficient 1. So if we do that, we have y equals 1 minus x plus x squared minus x cubed plus x to the 4, so on, so forth. Now, obviously, we need to add some numbers back. So if you write minus x here, and then plus x squared minus x cubed plus x to the 4. We've 1 minus 2x, that checks, so we have 1 minus 2x from here, and then x squared. We haven't got an x squared term, so we add another x squared minus, well, right now the count is at minus 2x cubed for the x cubed terms. So we write that as minus x cubed plus x to the 4. And essentially where we get with this is we have sort of like this, like a list of series where each time we're getting rid of one term, so on and so forth. I won't write it out, but if you evaluate each, here we have first term 1, and then we have common ratio minus x, and then here we have first term minus x, and then all over 1. Since the common ratio is still minus x, we'll always have the same denominator. So if I quickly do the next one, first term x squared all over 1 plus x, and then for this one, minus x cubed plus 1 over 1 plus x. So now we just need to sum all these. So we can just sum our numerous sum to infinity. So we have all over 1 plus x, 1 minus x plus x squared minus x cubed plus x to the 4, and so on and so forth. Now realize that this denominator is just another sum to infinity with first term 1 and common ratio minus x. So we have 1 plus x on the bottom, and that's all over a denominator 1 plus x. So that just becomes 1 over 1 plus x all squared. Same answer, just a different way of going about it. So that's all for this video. Hope you enjoyed the different styles of solving these converging series, and we'll be back soon.